Okay, this is the second, number 2, video for the STAAR Foldable. We're going to kind of catch up what we didn't finish on Monday and then do our new. Alright, we skipped this in class because you already had a video to watch, and so we're going to finish constant proportionality, and then you're going to have to jump into where it says square roots. But we've already finished this part. We don't have to worry about square roots. We're going to be talking about the Pythagorean theorem part. And then we're going to jump even more to the very, very last page before, at least on mine, before the flap of dimensional analysis. Okay? I'm doing all these all real fast because we've just hit this Pythagorean theorem and we already started on this. So, let's get started. Alright, constant proportionality. Alright, I gave myself notes so I could remember which ones we needed to work on. Okay, we started this right before you left. Constant proportionality is just another way of saying slope or unit rate, okay? And how you find rate or slope or unit rate, all those things are the same thing, is you have to divide. So there's going to be lots of division in here, okay? And they also like to keep it in fraction form as much as possible. Notice all of these are fractions. This is what we did in class. They like to keep them in fraction form. So if you can, kind of write this, fractions. But you have a calculator that does fractions for you, so no worries. All right. So now let's talk, we've done it in word form, which is essentially we've taken and divided to find the unit rate. And that will tell us how much it is for each ring or each product. We did it for here for 6 free throws in each minute. You just had to divide. Alright, same thing goes here, but when you have it in a table, you have to find 2 or more points, preferably where it intersects with the line, like right here, and right here, and right here. Okay, and then you find the XY value and then divide. But this is incorrect. You do not divide XY, you divide Y over X. Okay, so it's always the Y over the X when you're finding unit rate. So we would have to divide on this very first one. It's going to be 20, that's the Y, over 5X. 40 over 10. And 60 over 15. So in your calculator, very quickly, you can just divide. You just do alpha, and you go 60 over 15, and you get 40, or you get 4. And then I'm gonna, so I don't even have to worry, I'm gonna change that to 10. 4 again. I'm just and 4 again. So my K is 4. Boom, easy peasy. Okay, same thing goes with this one. Alright, we first go, this is 0, 0, so it would be 0 divided by 0, or 2 over 3, or, and I don't know if you can see it, 4 over 6. It's kind of where the arrow is, okay? So, if you look there, I can do alpha, stat plot, 2 over 3. Huh, well, it's as low as it can be and it still stays in fraction form. Well, let's check it with the next one. 4 over 6 reduces to 2/3, so they both reduce to 2/3, so 2/3 is my constant. Is it okay if it's in fraction? Yes, should be your answer. Okay, now if we use a table, identify the independent x and dependent y with each problem. Divide the dependent and independent to find k. So what does it want? It wants you to divide each one. Alright? And they get really tedious, but you do need to check them. So in this case you would do, I'm just going to kind of cheat, 4 over 20, 5 over 25. So alpha stat plot, 4 over 20, you get 1/5. Now let's check 5 over 25, 1/5. 6 over 30, 1/5. So my constant is 1/5. So there's my k. Okay? Same thing goes here. Now, you should always check. Look for a pattern. I skipped this part, but it's very important to pay attention. So, I only checked 3 of them. I should check these others. But I logically think about it. This is going up by 5, correct? So it's 20, 25, 30, 35, 40. That stays constant. And if this stays constant, I know it's going to work no matter what. So 4, 5, 6, 7, 8. That stays constant too. So this is going to stay constant, so I'm safe. Okay, let's try here. Alright, I have to find my constant by going 12 divided by 2, 30 divided by 5, because it's x, because it's y divided by x, and then 48 divided by 8. So 12 divided by 2, 30 divided by 5, 48 divided by 8. Notice I did all these with just division. I can do that because that's all a fraction is doing it by division. So if I wanted to, I can prove to you with this next one, 66 over 11, that me doing it with in fraction form doesn't matter. See how I got 6 no matter what? It just will be easier sometimes if you do it this way, but sometimes it's easier to do it the other way. Remember, fraction, all a fraction is mean division. So, alright. I'm going to do one more, and then we're going to, I'm going to leave you to do this one. Okay. So, this one, well, let's do 12 divided by 2, 30 divided by 5, 48 divided by 8. So, notice that these are the exact same numbers. It took me a second, but I figured out real fast that they're exact same numbers. Alright, so, those we've done. I want you to try to do this one. Okay, that's all you have to do with this. Now we're going to jump and kind of change our thought process from proportionality into Pythagorean theorem. Alright. So, how you find that section is here are square roots. We've already answered this. Squish it to the side. I don't need it anymore. Okay? So now I just need this. Or I don't need it. I wanted to reference back, but we're not working on it right this second. What we're going to work on is this part. You should have already cut these out. We're going to write under it. We're going to write to the side. We're going to really fill this up. Okay, Pythagorean theorem. Alright, here is Pythagorean theorem. The only part that's very, very important is that you recognize C is on its own side. A and B, remember, it doesn't matter. Now, I want you to flip open and I want you to draw a right triangle. Because remember, Pythagorean theorem only works on right triangles. put the little right angle wherever you meant for the right angle to be. Okay, and remember, C is very important, so we have to find it first. You look for the right angle, and whatever is across from the right angle is your C. Okay? And again, A and B doesn't matter, but it's the other two sides. So this is a picture form of this equation. Okay, so now let's talk about Pythagorean triples. This I added or put on here to help you out. Its purpose is for you to easily see the ones they like to use a lot. These are Pythagorean triples that always work out. Okay? And they love to use this one. We've used this one several times in class. This one we've used several times. This one's not as common, but still used a whole lot. And you can check it because remember, it's a squared plus b squared equals c squared. So remember, the longest side is always c. So you would do 3 squared plus 4 squared. Find what that equals. It equals 25. And then find what c squared is, which is the largest number, is 25. Do those two numbers equal each other? Yup. Same thing comes here. 5 squared plus 12 squared should equal what 13 squared is. Does it? Yup, it does. So, same thing here. 7 squared plus 24 squared equals 25 squared. Yep, those equal each other, okay? So these are just easy, simple ones to kind of memorize. So you just need to remember these, okay? All right? There's nothing really that profound about these other than it can make your life easier. If you start recognizing that this, if they only give you a 3, a 2, and a 3 and a 4, you know that other side's going to be 5 without having to work it out. If they give you 5 and a hypotenuse of 13, you know the other side is going to be 12. These are ones that you can memorize and not even have to solve because you'll already have the 3 numbers that will make up Pythagorean theorem. You can also do multiples of these. So if I were to multiply each one of these by 2, like 3 times 2 is 6, and then 4 times 2 is 8, and 5 times 2 is 10, that's also a Pythagorean triple. Like that also works out. I can prove it. 6 times 2 plus 8 times 2, or squared, equals 100, and 10 squared is 100. So even multiples of these are, you could multiple by 3 and go 9, 12, and 15. And that is also a Pythagorean triple. So these are just good ones to remember, okay? There's nothing really to do but just memorize these. All right, now to get to the nitty-gritty and actually solve something. All right, so Jason has a ladder, and oh my gosh, the quintessential Pythagorean theorem question is about some ladder leaning against a house or a tree or something. It's crazy. They always use these. So, Jason has a 26-foot ladder against a wall. The bottom of the ladder is 10 feet away from the base of the wall. How high is the ladder? All right. Draw yourself a picture. And guys, I am no artist. I am just simply going to draw my very rickety, odd-looking ladder. There's my odd-looking ladder. And then I'm going to label its pieces. This right here, they said, was 10 feet away from the wall. So that's 10. They said the ladder itself was 26. And we don't know this part. This is the missing part. Okay, that's the missing part, and you can't see it very well. So, I taught you to build a table. A, B, C. Okay? And this is side length, and this is area. So we put what we know. First of all, we know this is the right angle, so I know the 26 is my C. So this is 26, and I know, I'm going to say this is 10, and I don't know that. Okay? So, here, let me do it a different way. I don't know if it's going to show up. But C I always highlight because C is the important one. Okay? And so, if I know C, I know I'm going to have to subtract because everything has to equal C. Alright, so what is 26 squared? 676. Okay? 10 squared is 100. And I don't know this, but how do I figure it out? I have to subtract. And I get 576. And how do I find the side length? Remember, I have to square root 576 to equal x. So second, square sign, 576, and I get 24. So x is 24. So my ladder is 24 feet. Okay? That's how you solve a word problem. Now let's try to solve just a basic problem. Okay? Again, you find your right angle, which is right here, and you look for your hypotenuse. In this case, it's going to be, our C is what we don't know. We know A and B. Again, I'm all about the table. So build your table. A, B, C. Okay? We know this is 8 and 18. Remember, we don't know this. This is the part that's missing. So we get to add this time, not subtract. So we have to square to find the area. 8 squared is 64. 18 squared is 324. And we add those two together and get what we go here. It goes here. You get 388. Now, this is the part y'all guys forget, but notice it has to be the largest number, but not quite that large. We have to square root it. And you get 19 point, and let's just round to the tens place. This 9 is going to tell the 6 to become a 7. So 19.7. So your question mark is 19.7. If you like the Pythagorean theorem way, same things go. A squared plus B squared equals C squared. A is 8 squared plus 18 squared equals C squared. Alright, this is 64, this is 324. You add them up and you get 388 equals C squared. Square root them both. C equals 19.7. Whichever way you like it, if you like it in this or you like it in a table, I don't really care. Okay? Same thing goes with this one. If you like the Pythagorean theorem way of solving, a squared plus b squared equals c squared, it would look like 10 squared plus, we don't know b, and we know this is 26 squared. So then we would have to square this and get 676. We don't know b squared, and this is 100. Subtract 100 on both sides. You get 576. Then you have to square root both sides. So b will equal 24. Guys, the work is the same. If you like your table, which is how I taught you, or if you like it with Pythagorean theorem, have them both written down so you can kind of make your choice. Okay. Last but not least on this part of this video, dimensional change. Hey, remember, we taught it PAV 1, 2, 3. Remember, when you're dealing with scale factor, you multiply that by 1 if it's perimeter, by 2 if it's area, or 3 if it's volume. Okay, that's all this is. If I can take my little note off. Alright, perimeter. What is the perimeter of the smaller rectangle? Alright, so looking at this example, you have to find perimeter. So this side is 6, so this has to be 6. This is 10.5 because of that. So you add all the sides. That's how we find perimeter. So 10.5 plus 10.5 plus 6 plus 6 equals 33. Alright, what if we doubled the dimensions? That means times 2. So it's asking what would happen if we doubled the base. So what is 10.5 times 2? 21. What is the height if you double it? 6 times 2 is 12. So 21 plus 21 plus, 12 plus 12 would equal 66. Or you can do it this way. This is the long way. This is the hard way. Or we can have already discovered this. We can do 33 times 2 and get the exact same thing. 33 times 2, because you only do it to the first power because of PAV 1, 2, 3, and you get 66. Isn't just multiplying the easier way? That's why we went over dimensional change. Because you can do it this way. It's always a way to do it, but it takes more effort than it should. So it says what relationship between the perimeter of each triangle or each rectangle. Okay? And so what it's saying is this is 21, this is 12. It's the scale factor of 2. So that's what it wants. So what effect did it have? It doubled. Alright? Remember, what if it was asking for area? Okay? So you can always check it with area. 10.5 times 6, 10.5 times 6 is 60. So the area of the small circle is 63 feet squared. Okay? That's the area of the small one. Again, our scale factor is it doubled its dimensions. Alright? So we can double its dimension. Well, we know it's the area times the scale factor cubed because it's area. So we know the scale factor is 2, so 63 times 2 squared. So put that in your calculator. 63 times 2 squared is 200. So this one's right here has an area of 252 feet squared. That was pretty easy. I could have also, now that I'd already done all this work, checked myself. 21 times 12 is the same thing. So I know my answer's right, but so I didn't even have to do any of this work. I just had to find it by multiplying, and then do scale factor squared, and boom, I get my answer. This dimensional change is a quick way. PAV 123 is meant to help us get faster. It's not necessarily the only way you can do it. The 7th grade way is doing this. The 8th grade way is finding the scale factor, squaring it, or finding the scale factor and multiplying. But both ways work. I'm not saying what you learned in 7th grade is bad. It's just the foundation. Okay, this is a long video, so I'm done. Sorry I had to make you watch it. You only have that one question to finish. All right, bye.